Hello class and welcome to the session. In this session we're going to talk about auto transformers in detail. So what are auto transformers and how do they apply to transformers in general and its applications? So the truth is auto transformers have only one winding. So how does a single winding work as both primary and secondary coil? So when it's talking about transformation ratio, we're talking about turns in primary, turns in secondary, and transformation of power from the primary coil to secondary coil. Now, how come a single winding, a choke, work as a transformer? So this is what we're going to study in this session. So we look at the construction of an auto transformer. It's very simple. We have a toroidal core, which is a circular core. We have our copper winding, which is wound around the core, and we have our contact brushes or rollers, where we make contact with multiple taps made on that single winding. And we have a support structure to hold it so that we have a dial to turn it, where we can have the contact moved from point A to point B. So now, since it has only one winding, the core is a circular ring, the efficiency is higher, the coupling of the inductance of the coil is much higher, and the leakage reactance is much lower. So talking about efficiency, it's an efficient way of working with the transformer, but there are some advantages and disadvantages, and the way it works is a little different. So we will study that in detail. So the moment you look at the first diagram on your primary and secondary, you notice that the diagram looks similar to a voltage divider with one little difference. A voltage divider can be used to get a voltage from 0 to maximum. In other words, if I apply 10 volt, I can get a voltage from 0 to 10 volt on my secondary. But the beauty about auto transformers, I can go beyond 10 volt on my secondary. If I apply 10 volt, I can even get up to 12 volt on my secondary, having a control over the turns ratio. So it's having a tap and having the number of turns on the secondary be a little higher than the primary, though it's one single winding, the number of turns being considered can be changed. So auto transformers have little advantages in that way. So it's very useful and very practically used in voltage regulation. For example, you want to do a lab experiment, you want to change the voltage from 0 to maximum and see the reference with the way in which the output responds, you use an auto transformer. And the practical application would be an induction motor startup. You know that high starting currents are they're available, are predominantly what damages induction machines. So we reduce the starting current by using different methods. One such method is using an auto transformer. So I apply part 50 to 60% of the applied voltage load through an auto transformer to the motor during the starting condition, and then after the delay I switch it off and then give the direct voltage to the motor, and it works perfectly fine. So this is a pretty practical application of an auto transformer. So other than motors, induction motors, the other application would be boosting up the voltage in cables, especially in distribution networks, to compensate the voltage drop. So when I have a long distribution cable, there would be a loss due to the voltage drop in the cable. And I want to compensate it. The best thing I could do is add an auto transformer and be able to increase the voltage from 230 to 240 maybe. Example, if my primary side, the destination voltage is 230 and I want 240, I put that on my primary side of my auto transformer, the P is missing, and have the secondary have a little more turns to be able to get to 40 volts. So I'll be able to get a voltage a little higher by compensating the voltage drop in distribution networks. And it's used in electric traction. When you talk about electric traction, it's electric trains. Electric trains do have universal motors, which are basically series motors connected to AC power supply. And I want to do speed regulation, I want to have uniform speed regulation, then I use an auto transformer to be able to regulate it. And auto transformers these days are motorized. In other words, the center dial can be remotely controlled with a motor that's sitting right inside the core, can turn this brush all the way from point A to point B remotely. So there are motorized versions of auto transformers which can be controlled by a servo motor, which is installed right inside the core. So you have a servo motor in the center which controls the dial. So you can either have it turned by hand or it can be controlled from a remote location using a servo motor which is right in the center of the auto transformer. Now, how does it work? We talked about two winding transformers. We're talking about turns number in primary, turns in secondary. Now in this case, there's only one set of turns. So how does it work? Now the most important thing is you need to know it's working before you start turning the dial on an auto transformer. So we notice that when you turn the dial, the voltage changes. How does that happen? So understanding that is basically, if you have the voltage V1 applied to primary and V2 is the voltage on secondary, which is applied to the load. You have a current in primary, which is I1, and you have a current in secondary, which is I2. The turns between A and B is considered as N1, and turns on N2, which would be the center tap C, and B would be the turns of N2. Now, if you ignore the no load current, the leakage reactance, and the losses of the transformer, we could say that the transformation ratio K is equal to V2 by V1 is equal to N2 by N1 is equal to I1 by I2. Why is I1 by I2 inverse? Is because voltage into current is equal to power. So when the voltage increases, the current reduces. When the current increases, the voltage reduces, to talk about the power being transferred from primary to secondary. So that's the inverse. So when I combine it, yes, power will be common. So since the voltage is increasing, the current will reduce. So in that way, V2 by V1 is equal to N2 by N1 is equal to I1 by I2, your transformation ratio. Now, if my transformation ratio K is close to unity, the efficiency of the autotransformer is higher, because I'll be able to, when I compare it cost to cost for a 3 kilowatt application in comparison to a 2-winding transformer, it would be much efficient, much lower cost, because it's only one set of windings, and it's much more efficient to operate. But the disadvantages, you can't be able to have great voltage changes. For example, I want to do stabilization. I can do fine tuning of voltages between plus or minus of the applied input voltage. And it's a very good application for stabilization using autotransformers in industrial application. So when I want to have a 3-phase autotransformer, all I do is stack up 3 different single-phase transformers to be able to meet my requirement. The only difference is that all the 3 dials are connected together with either a hand dial or a steering to be able to steer it from point A to point B as voltage gradients as low as as low as 0 to your applied voltage. And that's the beauty of autotransformers. Now, what we conclude is, when you have your transformer loaded, talking about your autotransformer loaded, your part of your secondary current comes directly from your power supply, and the remaining part is coming from your transformation action as your self-inductance. So the applied voltage will reduce the reluctance path on a primary to cause higher fluxes to flow. Higher voltages to be induced in your secondary, because there are more number of turns in your secondary, being the same winding having more number of turns. So you're considering more turns on your secondary than your primary. The remaining would be a transformer action. So more or less, your primary current is your secondary current, but the way it's constructed, the way it obtains its power is through the same. It's due to self-inductance and transformer action combined with currents directly from primary to secondary. There are some disadvantages. You can't do much voltage regulation like plus or minus. You can't do a great step up or step down. You can do step down, but you can't do great step up. But on the and sometimes when you have a break in your coil, high voltages can apply to the secondary, which is a failure. Other than that, it's got a lot of advantages. It costs a lot lesser when you have K as close to unity. It has got better regulation of voltage compared to a 2-winding transformer. The losses are much lower compared to a regular 2-winding transformer for the same rating. For example, I have a 3 kVA auto transformer to a 3 kVA 2-winding transformer. The auto transformer will be much more better, or have less losses, because your core is toroidal and your flux is perfectly circular, flows in a circular path, and there's less points for leakage of reactants. There's less sharp points for the flux to leak out. In that way, it's much more efficient compared to a 2-winding transformer. So this is it. If you have any more questions on how autotransformers work, we would see a couple of experiments too when I covered them as a video in the lab. And for now, this is autotransformers. If you have any questions, please drop me a message and I'll be able to answer those questions for you. And for those who have not taken up the test, please join in the class and engage in the test and have it completed at the earliest. If you have not, please drop me a note and I'll have it activated for you so you can complete the test at the earliest. So that's it for now. Thank you and have a great day.